All right, welcome in everyone. My name's Nate. Today we're going to be talking about one of my biggest math tips. I'm just going to loosely call this the puzzle method. It's not like a real method or anything like that. This is just something that I've made up to make my idea of what I'm trying to get at here with my math tip make a little bit more sense. But basically, this is just a way that as soon as you are pretty comfortable with the equations, this is going to make all of those questions that you have to do use multiple equations at once. It's going to make those a lot easier, hopefully. So the idea here essentially is that if I just draw like a little puzzle here, we'll draw a square. Let's just say that the puzzle looks something kind of like this, I guess. You're going to see here that I am terrible at drawing puzzle pieces. I guess this is my puzzle, whatever. But let's just say that this is the piece that's going to give you your answer. This piece right here, the top right corner, that's the final piece. What I'm saying is that basically we're going to start with this piece, and then we're going to look at what this piece connects to in order to figure out how to actually solve the math problems that we're given. That's loosely why I call it the puzzle method. Like I said, it's not necessarily like a real thing. It's just something that I'm making up. But it's going to be best explained with an example. Right, so here is the example that I'm going to give. That a biomedical engineer designs a microfluidic device used to deliver a brief pulse of ions through a narrow channel to stimulate cultured neurons. Great, that's just information that's not really helping us out here. During one trial, a total charge of 6 millicoulombs, so I'm going to write that really quickly. Charge is Q, that is 6 millicoulombs, passes through the channel uniformly over 3 seconds. That's a time. Time is equal to 3 seconds. The channel has an electrical resistance of 500. That's resistance, 500 ohms. What is the electric potential difference across the channel during this trial? So basically, we are looking for voltage. So I'm going to use this information that we were given to try to figure out what is the final equation that I'm going to be using. So let me just start regurgitating some of the equations that involve voltage. We have P is equal to IV. We have Q is equal to C times V. We have E is equal to delta V over D. And finally, we have V is equal to IR. So basically what you're looking for, in addition to the missing variable, so let's just ignore that for a second. We don't have V in any of these. That's what we're trying to solve for. We're looking for an equation that is only missing one other variable or none at all, right? If there's nothing at all, like if we are given, for example, both power and current, great. We're using the first equation, we're done. But in this scenario, as you'll start looking through some of these equations, we're missing, in addition to V, we're missing another variable for all of them. So what you're essentially doing is, in addition to the variable that you're looking for an equation that only has one other variable missing. So just as an example, looking at IV, do we have a way to solve for P? Probably not, because P is equal to IV, and I didn't give you power. P is also equal to work over time. I didn't give you anything like that either. So basically, that's probably not going to help you. We don't really have a really easy way to solve for P. We do, however, have a way to solve for I, because I is equal to charge divided by time. So just as I'm going through these, I do have a way to solve for I. Notice that I'm not asking myself, do I have current? I'm asking myself, do I have a way to solve for current? Right? That's usually is going to be a much better mental way to make sure that you're actually checking through all of the different equations that you can use. Ask yourself if you have a way to solve for it rather than just asking yourself if you have current. Right? We do have a way to solve for current. It is charge over time. Gave you charge, but we're missing capacitance. So maybe this one will work as well. That's the other variable that we're missing. I did not give you an electric field, and I didn't give you a distance. So basically, we're not going to use that one. We're also not going to use P is equal to IV. Looking at this last one, I directly gave you a resistance, just like I gave you a charge, and I gave you a way to solve for current. So notice, basically, these two equations, Q is equal to C times V and V is equal to IR, basically, we're only really missing one variable, right? We're the only thing that we're missing is V. I gave you a way to solve for I, and I gave you a way, I already gave you Q. The problem with Q is equal to C times V is we don't really have a direct way to solve for C. That's the problem with that one, whereas in V is equal to IR, I literally directly gave you both. I gave you I, because we can just do Q divided by T, and I already gave you R. So essentially that's what I'm saying is we're going to be using that equation. We're going to be using this V is equal to IR equation to solve for our voltage. So we're first going to solve for current. I is equal to 6 millicoulombs. This is the same thing as saying 6 times 10 to the negative third coulombs divided by time, which is 3 seconds. Right. If you struggle with scientific notation math, I have another video that should help out with it. I also have an app, a web app, that has all of the SI prefixes that will make memorizing that milli is 10 to the power of negative 3 really easy. That will make stuff like that easy. But we're just converting everything into the standard units just so we can make the math a little bit easier. So all I need to do here is just divide these two numbers by each other. So we end up with 2 times 10 to the negative third coulombs per second, which is the same thing as saying amps. 2 times 10 to the negative third amps. So now that we have the number of amps that we want, we can then just plug this number into V is equal to IR. V is equal to IR, which is equal to 2 times 10 to the negative third amps times our resistance, which is 500. I'm going to rewrite that as scientific notation really quickly. 5 times 10 squared ohms. So then just using our scientific notation rules, 2 times 5 is 10. I'm going to show you a little bit of a shortcut here. I know that the answer has to be B because notice that our prefix starts with, our number has to start with a 1 essentially. But just to finish that out, we get 10 times 10 to the negative first power because negative 3 plus 2 is negative 1. And then from there, that's volts. This simplifies basically to 1 volt. And the answer is B. So just taking a step back, right? We listed out the variables that we were given, but we're not just regurgitating equations that have these variables. We're looking through the equations that have the unit, that have the variable of what we're looking for in that equation. We're starting there. And once we list out those equations, we're just looking for an equation that, in addition to the variable that we're missing, is only missing one other variable. Basically, every other variable has to be accounted for in some way. Maybe I didn't directly give it to you, but you have to be able to solve for it. That's why we chose the V is equal to IR equation, because it was missing V. That's what we're solving for. But I directly gave you resistance, and I directly gave you a way to solve for current. So that's the equation that we're going to be using. That's the first example. Let's do a different one just to see if this truly makes sense. Using this other problem that I've given you, a sealed container holds 1 times 10 to the negative 26 kilograms of a monoatomic gas that are moving with an average speed of 500 meters per second. So we have a mass. The mass is equal to 1 times 10 to the negative 26th. And the average speed is equal to 500. One thing that I'm going to show you really quickly, because I'm about to do the math in this way, notice that all of these answer choices start with completely different numbers. So basically because of that, we can actually ignore all of the zeros. We can ignore the scientific notation, and we can ignore 500. The reason for that is that's just going to change how many zeros are coming after the number, which we don't really care about because notice, like I said, like if we do the math and we get that the number is supposed to be 9, then that means that the answer is going to be D. If we get that the number is 3, then that means the answer is going to be B. You'll see what I mean in this example right here. So basically that's just a cue that we're not going to have to do as much math as you probably think so. So just trust me. Let's just kind of pretend that the mass is equal to 1 kilogram. Mass is equal to 1 kilogram. And that the velocity is 5 meters per second. Like I said, it's going to sound kind of weird, but just trust me for a second. Assume that the gas behaves ideally. That's great. Based on this information, what is the temperature of the gas? And they give us K. K is equal to 1.4 times 10 to the negative 23rd joules per Kelvin, which, like I said, we're just going to kind of ignore all of that scientific notation stuff. Let's just pretend K is 1.4. Right? Okay. So with that being said, like I said, puzzle method, we're going to start off with the temperature. We're looking for an equation that has temperature in it, right? And there's a lot. Your brain probably immediately is jumping into like PV is equal to nRT. Maybe you're thinking of entropy is equal to heat divided by temperature. Maybe there's also in your brain like kinetic energy is equal to 3/2 times K times T. Something like that. basically you might be thinking through all of the equations, and as long as you understand this equation right here, that like this is an equation that you need to memorize that you might have seen that you just kind of ignored. You do need to memorize this equation. Once this one shows up, basically that's what I'm trying to get at, is asking yourself, okay, we are looking for temperature. So in all of these equations, we're looking for temperature. And in this last one right here, notice that I gave you the Boltzmann constant. We have that. I think that's the Boltzmann constant. It's possible that it's not. It's okay if it's not, whatever. And do we have a way to solve for kinetic energy, right? So if you're thinking through the different ways to solve for kinetic energy is equal to 1/2 mv squared, right? Pretty much every time and always. And I gave you a mass and I gave you a velocity. So we do have a way to solve for kinetic energy. Therefore, we can basically just solve for kinetic energy first and then throw it in this equation to solve for T. So that's what we're doing here, right? So let's first solve for kinetic energy. Kinetic energy is equal to 1/2 mv squared, which is equal to basically 1/2 of the mass is going to be 1. The velocity is going to be 5. So this is going to simplify to 1/2 times 5 squared, which is 25, which is going to give us 12.5. So that is our kinetic energy, which has the unit of joules. So now we can just plug this in, that 12.5 is our kinetic energy, which is equal to 3/2 K times T. We were given K. So basically 12.5 is equal to 3/2 times 1.4 times T. Rearranging everything over here, we're going to have to multiply the 2 over to the other side. So that's going to give us 25 is equal to 3 times 1.4 times T. Putting these two numbers together, if I'm estimating, I'm going to say that that's about 4.5. That's good, close enough for me. So basically we have 25 divided by 4.5 is going to give us T. Right, simplifying this is basically going to be a number that's just barely above 5. It's like 25 divided by 5 is 5. So it's just going to be a number that's slightly bigger than that. So our temperature is going to be roughly 6. 6 something. Answer has to be C. That's what I'm trying to get at, was that you can kind of ignore all of the zeros, because basically as soon as you get that the number is going to, your answer choice is going to start with a 6, you don't have to worry about how many zeros come after that. The number of zeros, because of the scientific notation, is not going to change this number at all. It's not going to change the 6 at all. But long story short, that's the puzzle method. Basically, write the equation that is going to solve your the final equation that you're going to be using first. Write that final equation first. Then once you're looking, basically write out all of the equations that could be solving for that final variable. You're looking for an equation that has that final variable in it. For this case, it's temperature. And through those equations, you are looking for an equation that basically you either are given every other variable or have a way to solve for every other variable, right? Going through these other options, I gave you no way to solve for pressure, volume, number of moles. Maybe there's a way. No, there's no way, because we don't know what the gas is, so we can't even do that. Like, obviously we can't use this equation. It's not going to help us at all. We weren't given those variables. I didn't give you entropy, so that's not going to help you. I didn't give you heat. That's not going to help you either. Where in the equation that we ended up using, this kinetic energy equation, I gave you the Boltzmann constant, and I gave you a way to solve for kinetic energy. Right? Basically framing it that way makes it much easier to see, like, okay, yes, this is the equation that's going to give us our final answer. We just have to work backwards. And that's what we did. We solved for kinetic energy, plugged it into the equation, solved for T, and we got 600 specifically. So that's basically my summary of the puzzle method. Basically all you're doing is write out the equations that have the variable that you're looking for, and then just pick the equation that you essentially have everything that you need to solve for. It's basically what I'm trying to get at is it's easier to work backwards with these equations than it is to work forwards. A lot of my students, they get this information right here, mass, velocity, and the Boltzmann constant, and then they're just going to throw out a whole bunch of equations that include all of that stuff. I'm 95% sure this is not the Boltzmann constant. I'm going to look that up really quickly. It is the Boltzmann constant, right? Okay, vindication there.
Vindication!
But long story short, I just find that a lot of my students who end up regurgitating a whole bunch of equations based on the variables that you were given, that's going to take you significantly longer than if you write out equations with the variable of the answer choices. Basically, this is just making it to where you have your eyes set on where you're going, and you're just listing out equations that just will help guide you on how to get there, if that makes sense. Whereas if you're just listing out equations for the things that they gave you in the question, you're going to have no clue where to go. You're going to have no clue what equations you're supposed to be working next or using next or anything like that. You're just going to be randomly combining things until you maybe stumble upon the answer. So list out the equations for it that include the variable that you're looking for, and then from there just check through those equations to see if you have one that they've given you everything that you need. Not necessarily that they've directly given you every variable, but maybe they give you a way to solve for each variable, right? So yeah, basically in my course that I'm going to be releasing sometime around the end of January, early February, we're going to be doing a whole bunch of practice with this. I'm not only just in general, there will be a section that we just kind of holistically practice this, where I'm basically going to show you the equations and make you pick which one we're going to be doing and stuff like that. I'm basically going to help you refine this skill. But we're also going to be doing a whole bunch of math practice just with these equations in general, so that you can get in the hang of having to use two different equations to solve for one variable. So I highly recommend checking that out. You can sign up for updates on whenever I release that at the link in my description. Most of you are probably going to be watching this in my actual course, if I'm being honest, but that's my this is pretty much one of my biggest math tips, in addition to being comfortable with scientific notation. This just makes it way easier for you to find equations that you're supposed to be using, way easier to do math, should make it a lot faster. And like I said, if you need more practice on this, we'll do a whole bunch of practice in my course. All right, thanks. Please, if you haven't already, go ahead and subscribe. Really helps my channel out quite a bit. Also, obviously I do a whole bunch of MCAT stuff. That just makes it easier for me to know if I should or shouldn't keep doing this, but appreciate the support. Hopefully this helped, and I will see you guys soon.